Hello everyone. I think I'm audible to everyone of you. So good morning everyone, and welcome to this community class as well as like regular classes for statistics. So I think in last class I was talking about like very basic things into statistics, like what is a different kind of a variable that we have inside a statistics. Plus we have discussed that okay, so what is a significance of mean, median, mode, variances, and standard deviations, and we have seen formula as well for a population basically, I would say. So for a population we have seen a formula, we have seen a mean, median, mode, and standard deviations, variance, and we understood somewhat, I can say, like a definition of each and everything. This is what we have done. Now in the same sequence, so we will try to understand that like what is a mean, median, mode of like a sample you will be able to calculate, and on top of that, so we will try to understand that what is a probability density function. So majorly in today's class, so we will be talking about that what is a probability density function, and based on that how I will be able to calculate basically a probability of occurrence of some of the events. So let's try to understand it, and let's try to find out that how these things actually works. So in last class, so we were talking about like how we can calculate basically a mean, or I can say average. So average for a population is nothing but summation of the entire data set divided by, I can say, like total number of the events or total number of the data set itself. So this is how we will be able to calculate a average, I would say, or we used to represent in terms of a mu. So mu is nothing but average of a population. So mu is a representation of a population, not a sample, just a representation, just a notation, I would say. It's nothing but summation of like all the data starting from I is equal to 1 till capital N, and I can say xi again. So at the same point of a time, so if I'm talking about, so this is about a population. So this is about a population. I think we all know that what is a difference between sample and population. So like population is nothing but if we are going to consider a whole data set for some scenario. So again, population is nothing but it's a subjective term, so it changes, I would say. So population sometime it can be like 100 data set is equal to population, or maybe 1,000, sometime maybe even a billion is not going to give you an entire population. It can give you just a simple sample. Now if I'll talk about a notation, if I'll talk about a notation for, I would say, so if I'll talk about a notation of a mean for a sample, so this is for a sample. Sample means nothing but a subset of the data. So if I'll talk about this one, so it's nothing but it's a X bar. This is the notation. So sample mean notation is X bar, and a population mean notation is nothing but this mu. So this is just a representation. And if I'll talk about a formula, so we used to represent these things by 1 by small n, summation of I is equal to 1 till small n, means till entire data set, and xi. So this is just a notation. So wherever I'm going to use x bar, just try to understand that okay, so I'm trying to talk about a sample, because in statistics it matters. I would say this kind of a notation is going to matter for a different kind of a statistical analysis going forward. In a T statistics or in a jet statistics, you will be able to see all of those differences very clearly. So it's completely fine. So if I'll talk about a population and a sample mean, so population mean is nothing but mu, sample mean is nothing but x bar, as per the notation I will be able to tell you. Now, so if we are talking about mean and median, so it is going to be same. So this is not going to change. I think we talked about that. Now, if I'll talk about a sample variances, so population variances is nothing but it's a rho square, or this one I can represent. This is called as a population variance. And again, if I'll talk about standard deviation of a population, it's nothing but a square root of the variance is called as a standard deviation. For like a theory wise, we have already discussed those things in a last class. So if you are not able to recall the theory of a standard deviation, maybe you can visit a last class lecture and you will be able to get it. Now at the same point of a time, so at the same point of a time, if I'm trying to represent a variances of variances of, I would say, a sample. So variance of, so for population, it's been represented by rho square in terms of variance. At the same point of a time, if I'm talking about a variance of a sample, it's been represented as small s square. It is just a representation, guys. Again, so there is a little bit of changes you will be able to observe over here. So in case of a population variance, this is how you can write: summation of I is equal to 1 till capital N, and then xi minus mu of a square divided by a capital N. This is something that we have discussed. So this is something that we have discussed in our previous classes, I would say. Now, at the same point of time, if I'm talking about a variance of a sample, so again, it's a little bit of changes you will be able to observe. So it's represented as a s square first of all, and then summation of I is equal to n till small n, and xi minus, so instead of mu you are supposed to use x bar, because mu is basically a notation or a representation of a mean for a population, whereas if I'll talk about a sample, so representation wise you are supposed to use x bar square divided by n minus 1. Now, many of you may ask a question that, okay, so here we are trying to divide by n, basically by capital N means by total number of the data. But here we are trying to consider n minus 1. What is a reason behind that? So yes, there is a mathematical proof also which is available. But as of now, if you'll ask me, so I'll tell you, like, okay, so whenever we are going to consider a standard deviation or maybe a variance of a sample, so in that case, in a denominator, or we never consider a total number of the data, because if you are going to consider a total number of the data, maybe you will not be able to get a exact, because based on the experiments, so based on the experiments, people have proven that whenever we are going to consider a subset of the data or a sample, so we are always supposed to take a data minus 1, means n minus 1 we are supposed to take based on the experiment. This is what I can tell you as of now. Yes, like I told you, there is a mathematical proof. So but still, as of now, this is the small differences that you will be able to observe. So in terms of a notation, variance is nothing but s square in terms of a sample subset of the data, or in terms of population, it's a rho square that you will be able to get. Now, at the same point of a time, if I'm talking about a standard deviations of a sample, so I think we have already seen that what is the standard deviations of a population. So it's nothing but this one, which is nothing but is equal to rho. So just you have to do a under root, and then you will be able to get the standard deviation for a population. Now, if I'll talk about the standard deviations of a sample, so again, it's not a big deal at all. So standard deviations of a sample is nothing but same. So under root of s square. So it will be nothing but, so under root of summation of I is equal to 1 till small n xi minus x bar of square divided by n minus 1. As simple as that. So this is what you will be able to get for a sample, and this is what you will be able to get for the population. So notation wise, just try to remember these particular things, because we will be using these things frequently again and again and again in our entire lecture. And again, there is a difference. There is a difference between a sample and a population that you will be able to observe going forward, because many statistical problem we are going to solve just based on these things. So I think formula wise, everyone knows that what is mean, what is median, what is mode, what is variance, and what is a standard deviations. And just remember this, because you are going to use it in your day-to-day life. Now, the next thing which I will be talking about is something called as a probability density function. So first of all, let's try to understand that what is a definition of a probability density function, and why and when we should use a probability density function, and what is the significance, or what is the uses, or like what is a meaning of using this probability density function. So I would say that a probability density function, I would say it's a kind of a mathematical function, so through which you will be able to find out a probability of occurrences of, so a different possible outcome in an experiment. So suppose if I'm trying to throw a dice, right? If I'm trying to throw single dice as of now, so it could possible that I will be able to get 1, 2, 3, 4, 5, or 6. So this is the only possibility that I have if I'm going to throw one single dice. So if I'm going to throw only one single dice, this is the probability. Now if I'll ask you a question that, okay, so what is a probability that you will be able to get 3? So you will say that, okay, fine, so it's 1 by 6 in general. So in general, you will say that, okay, fine, so you will be able to get 1 by 6. But if I'll tell you that, okay, fine, so suppose if I'm going to throw this dice twice, so what is a probability that both the time, so you will be able to get 3? This is the question which I can ask you. So this is the question which I can ask you. Or maybe let's suppose in a simple normal data set, right? So suppose if I have given you a result, suppose if I have given you a result or a mark sheet of a particular student, and if I'll ask you that, okay, find a mark sheet record for a particular student, maybe for a 2 3 exams. If I'll ask you that, okay, fine, so what is the probability that that student will be able to crack this exam, or maybe he will not be able to crack this exam, or she will not be able to crack this exam? So again, those kind of a questions comes under probability. I can ask you this dice problem in maybe other way as well, that, okay, fine, so if I'm trying to throw a dice twice consecutively, what is a probability that I will be able to get 6 both the time? Possible. Suppose if I'm going to throw a multiple dice at a time, what is the probability that I will be able to get maybe a summation of uh, 10, if I'm going to throw maybe like a 3 dice or 4 dice or maybe a 2 dice at a time. So these are the variety of the problem that we might have solved in our childhood related to a probability, I would say. So here also we will try to solve such kind of a problem by using a different kind of a probability density function. So there are a variety of a probability density function which you are going to encounter, and you can try to solve it. There are variety of the interesting problem which is which can come in between this probability density function, and many things we can cover in this particular place. So like I told you, so probability density function is nothing but it's a mathematical function by which you will be able to find out that what is a possibility of occurrences of this particular event in with the help of a given, I would say, a record, or maybe in between a given timestamp, I can say, or maybe based on some other parameter, you will be able to define, you will be able to identify that what is a occurrences of this particular event. Now, so again, if for example, if I'll just try to give you that, if we are trying to toss a coin, right? So we all know that if we are going to toss a coin, so either we are going to get head or we are going to get tail if I'm going to toss a particular coin. Now, so anyone can ask you a question that what is a chances that you will be able to get a single head? Possible. People can ask you a question that, suppose if I have a multiple coin, suppose if I have a 5 coin, what is the probability that I will be able to get at least 3 coin, or at least 3 head or 3 tail, right? So these are the questions. I think it's a very normal question which people can ask you, and I think we all have solved those kind of a problem somewhat. Like those kind of problem we have solved somewhere in our childhood, maybe in our 10th 11th 12th mathematics book. But here, so again, we will try to understand those things in terms of a statistics, that, okay, how we can solve it with the help of all of these probability density function, and how we'll be able to find out a result. And again, so in terms of a data, if I will be talking about, right? So suppose if I'm going to collect a data, now I can try to perform a different kind of a probability density function. For example, so suppose I have received a data about maybe a accident, right? So suppose if there is a road, and in this particular road, I would say, so accident happens and I have to, so as a part of maybe a government organization, So maybe I'm supposed to maintain, I would say, a services in this road, means EMS services, emergency services, or maybe like fire brigade services I'm supposed to maintain. Now, so how many fire brigade or maybe how many ambulance I'm supposed to deploy in this particular road? Because whenever government will try to plan for maybe like a new I would say a highway or any other highway, so for sure they always plan for event services, they always plan for this fire brigade, and a different things they used to arrange. Now, how people will be, or how anyone will be able to understand, or how anyone will be able to define that, okay, so how many vehicle I'm supposed to deploy in terms of an ambulance, or how many like a fire brigade services I'm supposed to deploy, or how many police station we are supposed to establish in a certain region, in a certain area. Because there will be a different kind of a regional problem that you are going to face in a different area, and based on some intuition, based on some idea, some data, I'm supposed to define all of those things. So again, if I will be able to find out somehow, hypothetically I'm talking about as of now, so hypothetically if I'm able to find out that, okay, so what is the average accident, or what is the probability that there will be a 10 accident or maybe 20 accident, or what is the probability that in between maybe 9 a.m. evening till 9 p.m. evening, 9 to 9. So what is the number of the accident which can happen? What is the probability that there will be a 50 accident or maybe 100 accident, right? So if I will be able to find out a probability, and if probability is too high in certain interval of the time, so maybe I can try to arrange immense services accordingly, right? So all of these things are possible. All of these things are possible if I have a historical data. That's a one thing. Second thing is, if I know how to fit those data in this probability density function. So there are a various different probability density functions that you are going to encounter, many other functions, many different functions you are going to encounter, which is very much important. And again, if I'll talk about implementation, if I'll talk about implementation of this probability density function in in Python program or in any other programming, it's basically a single line implementation, just a single line implementation. But I will not try to get into an implementation in a very first place. What we will do is, first of all, we will try to solve all of those things mathematically, because like I told you, in Python, so all those functions, all those libraries are already available. So at the end of the session, so we will try to take all of those things one by one. We'll try to understand all of those things one by one in terms of a Python programming. But as of now, as a beginner, so we will try to prove each and everything, and we will try to understand in terms of a mathematical expression, so that we can secure ourselves in both the way. Okay. So if I'll talk about a probability density function, so there are a different kind of a probability density functions, or different kind of a probability distribution function you will be able to get. So let's talk about it. The first function is nothing but, so it's basically a probability distribution or density functions. So first function or first operation or first thing that we are supposed to learn is called as a normal distribution. I think I have taken this name in my last class. Then second is nothing but Bernoulli's distribution. The third one is nothing but binomial distribution. The fourth one is nothing but uniform distribution. The fifth one is nothing but students t distribution. And a sixth one is nothing but Poisson's distribution. So these are the probability density function which is available, and for many of you, so it's completely fine that maybe this looks like an alien words, or maybe you never heard about all of these words so far so forth at any point of time in your life. It's completely fine, no need to worry about it. because we are going to have a discussion on each and every function, and these functions are very much important. Now again, like I told you, implementation wise, as a data scientist, you are not supposed to take a pain at all. You're not supposed to think about that, okay, so how tough this implementation will be, because for each and every kind of implementation, so there is a very simple library, there is a very simple API which is given in almost every programming languages, whether you are going to talk about a Python or maybe a R or maybe like some other libraries which is available in some other languages. So it is available. You are not supposed to worry about, you're not supposed to think about anything out of it. It's completely fine, but you will be able to implement these things in a much better way. You will be able to implement these things in a much better way if you understand all of these things mathematically. If you don't understand all of these mathematically, yes, there will be some kind of a confusion, there is some kind of a like at least some kind of a doubts you are going to get. But first of all, we will try to understand all of these functions one by one at a time, and then we will try to understand that, okay, so how these things is actually going to work. So first of all, let's try to start. So there is something called as a normal distribution and student t distribution. I will be talking about these things in very detail, because these two functions are a very frequently used function in case of a statistics in terms of a probability. So student t distribution is very much important. Again, normal distribution is very much important. So I will be talking about these things in very detail. But before that, let's try to close our discussion, which is a simplest one. So like a binomial, again, everything is simple, nothing is tough, I would say, but still. So let's talk about like a binomial distribution and maybe uniform, Bernoulli's, and a Poisson distribution. One by one, we will try to find out. So first of all, if I'll talk about this binomial distribution, I will be talking about binomial distribution so that we can finish our discussions easily on a binomial distribution. We can solve some of the problem, and then we'll get into a normal distribution and a student t distribution, because we have to discuss a lot about that. So here, if I'll talk about a binomial distribution, so let's see how it goes actually. Binomial distribution. Now, so binomial distribution is a kind of a probability density function which is been used when there is more than one outcome of a certain experiments that you will be able to get. So suppose if I'm trying to perform some kind of experiment, if I'm trying to find out that, okay, so whenever I'm going to toss a coin, so whether there will be a head or there will be a tail, or if I'm going to give an exam, so I'm in a confusion that whether I will be able to pass or I will be able to fail, whether I will be able to get more than 90% or maybe a less than 90%. So these kind of a things where you will be able to get two outcome. So either you will be able to get a success or failure, or maybe a zero or one. If you will be able to get, so if you will be able to get, so I can say that, okay, so those kind of a event comes under a binomial distribution. So now let's try to understand that what an all kind of a problem that I will be able to solve into a binomial distribution. So again, so whenever we are going to solve any kind of a problem into a binomial distribution, so whatever event that we are going to take, again, what is the meaning of event, what is the meaning of trial, soon we will be able to understand that. So whatever event that we are going to take, so all of those events should be independent of each other. So now let's try to understand it. So first of all, I would like to write a formula for this binomial distribution. So here I can try to write a formula for a binomial distribution in this particular way. So let's try to understand it, that what is actually an exact formula of a binomial distribution that you will be able to get basically. So fine. So if I'll try to talk about a binomial distribution probability functions, so it's nothing but occurrence of n when something has already happened, n by n, and p to the power n small n, q to the power capital N minus n. Or in a very simplest possible way, if I'll try to write this formula, so it's nothing but it's a n factorial divided by a small n minus n of factorial, and then p to the power n 1 minus p to the power n minus n. So again, I have written a capital N, small n, and all those things. What is the meaning of that? Let's try to understand it. So here, if I'll try to talk about these particular term, or if I'll talk about this one, so this is nothing but it's a probability density function or probability distribution functions for a binomial experiment. Binomial experiment is nothing but, so whenever you are going to perform some kind of experiments, so some kind of experiments, and if you are expecting some result like a 0 or 1, or maybe a success or failure. So in this case, and again, so both the events, success and failure event, or 0 or 1 events, are independent of each other. So in that case, you can try to apply these things in terms of a binomial distribution. So fine, each event should be independent of each other. That's the first condition that you are supposed to follow and fulfill in terms of a binomial distribution. And this is the formula that I have written. Now, as of now, if you're not able to understand the meaning of the formula, it's completely fine. No need to worry about that. I think in a couple of minutes, you all will be able to understand it. So it's, if I'll talk about this one, a probability of n means probability of occurrence of n when n has already occurred, or capital N has already occurred, is nothing but, so it always try to give you a discrete probability distribution which you will be able to get out of n successes, I can say, successes, I can say, out of total number of the trial. So this capital N is nothing but a total number of the trial that you are going to perform, and small n is nothing but, so for some event, so how many times you are able to get a success. So this small n, if I'll try to represent, so it's nothing but, so it always try to represent a success. And if I'll talk about capital N, so it always talk about a total number of the trial, a total number of the experiments that you have done so far, so forth. So again, there is a library which is available inside a Python, by which you will be able to find out these things. Now, this is nothing but, I would say, so whenever you will try to find out, or whenever you will try to expand this function, so this particular factor, I would say, it's called as a binomial coefficient. So this is called as a binomial coefficient, this entire term. So total number of the trial divided by total number of the successes is called as a binomial coefficient. And if you will try to expand this one, so it's nothing but, so NCN. So number of selection of n out of n, out of total n, or number of the successes out of the total trial, you can say. So if you are going to expand this one, you will be able to get this factorial. So it's nothing but NCN. So I think you might have heard about this combination, permutation, and combination. So this is nothing but a total number of the combination of a successes out of n trial. So this is how you will be able to iterate these particular things. So fine, guys, let's try to understand. P is nothing but a probability of the success, and Q is nothing but 1 minus P. So here Q is nothing but 1 minus P, or you can say, so probability of a failure, or probability of like a 1 minus probability of the success is equal to Q in this particular place. So let's try to solve one particular example based on the same thing, and you will be able to get these things in a better way. So here we have a question. Here we have a question that there is a hospital. There is a hospital. So in that hospital, there is a patient who is suffering from a particular disease. So let's suppose there is a hospital, and a patient is having maybe some kind of a disease, for sure, and that hospital try to provide a treatment for that particular disease. Now, so on an average, we have seen that out of 100, on an average, we have seen that out of 100, so 75% die all the time. So suppose there are 100 patients who is suffering from a certain disease. Out of that, 75% dies all the time. Out of 100 patients, on an average, I'm talking about. Now, so I have to find out that what is a probability that if I'm going to select. So this is the stats as of now of the hospital. So I have to find out that what is a probability that if I'm going to select six-person randomly, six-person randomly, then these person. So what is the probability that if I'm going to select a six-person randomly or six patient randomly, so out of those six-person, four will be able to recover. So this is something that we are supposed to solve. Again, I'm going to iterate my question. So there is a hospital, and on an average, the hospital track record shows that for a particular disease, suppose if I'm talking about maybe a lungs cancer or something like that, right? Or maybe let's suppose if I'm talking about just a corona as of now. So there is a hospital, and that hospital try to provide you a certain kind of a treatment, certain kind of a medicine for a specific disease. Now, for that specific disease, out of 100, 75 people dies. So it's completely fine out of 100. So I can say that the rate by which people are dying over here is, I can say, it's a 75%. So that is fine, that is true. Out of 175 people dies. Now if I'm going to select 6% randomly, I'm talking about basically a sample of the data over here. So if I'm going to select a six sample randomly or 6% randomly from that particular hospital, what is a probability that 4% will be able to recover? So this is something that I'm supposed to find out. I'm supposed to find out the probability that, okay, so 4% should be able to recover in this particular case. So fine, let's try to figure it out. Let's try to like find it out. So if I'll talk about like a number of the person who is going to recover, so suppose if I'm going to represent that thing by maybe capital X, so that is equal to, let's suppose, 4. Let's suppose 4. Now total number of the person or total number of the sample which I'm going to select out of 100 is equal to maybe 6. Okay, so this is something that I will be able to get. Now if I have to find out, suppose if I'll ask you a question that, okay, 75% people dies, so probability of recovery, what is the probability of recovery, or what is a percentage of a recovery, I would say. So you can clearly say that, okay, fine, so probability of a recovery is nothing but 0.25%, because 75% dies out of 100. So failure, probability of failure is equal to 0.75. And at the same point of time, if I'm talking about a probability of recovery, so it's nothing but 0.25 that you will be able to get. So not an issue, it's completely fine. So we know about a number of the recovery, that for that we are supposed to find out the probability. We know that, okay, fine, so out of how many people I'm supposed to find out these four success. So if you will try to correlate these things with the binomial distribution, so how you will be able to correlate? So first of all, let's try to think that why we should choose binomial distribution. So see, the thing is, so here, so we talked about a binomial distribution theoretically, and binomial here, bi. So if I'll talk about this particular word called as bi, so this binomial itself represents that whenever you are trying to perform some kind of experiments, and if you are going to get a success and a failure, just a success or a failure out of any kind of a event, in that case you can try to apply binomial distribution. Okay, so here also we are able to get either success or failure, means either person will recover or person will not recover. That is one thing, that is fine. Okay, now the second thing that we can talk about over here is so binomial distribution always try to give you a probability of success out of a total number of the trial, I would say. So here I can very clearly states that what will be, what will be a total number of the trial you are going to perform. Because what is a total number? I can say what is the total number of the experiments that you are going to perform. So just by looking into your question, so in a question I have very clearly mentioned that if I'm going to select 6%, means how many trials I'm trying to do? I'm trying to perform basically a 6 trials. Now, so out of that, if 4 are able to recover, out of 6%, 4 are able to recover. So total number of the trial is equal to 6%. So that is not an issue. It's completely fine. So I can clearly say that, okay, fine. So value of this one is nothing but a 6. So total number of the trial is equal to 6. Now, if I'll talk about this one, so it's nothing but I would say 4. Means for a success or for a failure, so we are trying to measure these things. Means out of 6 trial, what is a probability that 4 trial will be able to succeed? Then if I'm talking about a probability, so probability for this particular success, I think we know about that. So we know about a P. So probability of success is equal to 0.25. Now, so this is nothing but a probability of failure. So probability of failure is nothing but 0.75. So I think we know about a capital N, we know about a small m, we know about a P, and we know about a Q. Now, if I'm going to put each and everything in this binomial distribution function, so let's suppose a total number of like a trial is equal to 6 factorial divided by a total number of, I can say, maybe a experiment 4 factorial 6 minus 2 of factorial probability of a success. So probability of success is 0.25 to the power total number of the success. So total number of success is equal to 4 into 1 minus p, which is nothing but 0.75 that you will be able to find out, and total number of trial minus total number of success. So 6 minus 4. So if you will be able to do a calculation, now if I'll talk about a calculation, so calculation wise, if I'll talk about these things, so you will be able to find out that, okay, fine. So 6 factorial by 4 factorial, 6 minus 2 is equal to, like, again a 4 factorial 0.25 to the power 4 into 0.75 to the power 2. So if you will try to solve this one, you will be able to get around 0.032959. I already have this calculation actually with me. So this is a probability that you will be able to find out now. So you can very clearly say is that, okay, fine. So if you are going to select 6%, so there is a 0.03% chance that out of 6%, 4% will be able to recover. There is only a 3% of a chance. If you're going to multiply these things by 100, so exactly or precisely, I would say there is exactly a 3.3% of the chance that 4% will be able to recover out of a 6%, if this is the stats that you have, or if this is a record that you have. So this is what you will be able to define, or this is what you will be able to get out of a binomial distribution, out of this probability density functions. So it's very simple, guys, I would say. So I just know one single formula, one single small formula I know, and based on that I'm able to calculate this probability density things in a easiest possible way. Again, so if I'll talk about like a SciPy scikit library or SciPy statistics library, these functions are available just in a simplest possible form. You just have to call it, pass all the data, and then done. You will be able to get a result just in a single line. You're not supposed to do any kind of a calculation, but it's always good to know that in which case I'm going to, or I'm supposed to apply a binomial distribution. So binomial distribution you are supposed to apply all the time whenever you are going to get a by result, means you will be able to get a success or you will be able to get a failure. Okay, guys. So fine, binomial distribution. So we are, I think, we are able to solve one of the problem statement over here. Now, so let's talk about some other problem statement which is related to a binomial distribution. So we are going to solve many like a mathematical function, and we have a slide as well. So whatever like a mathematical operation that I'm talking about over here, so for sure we are going to share this slide with every one of you, and you can try to go through this one. Now, the next problem that we are going to consider, or next question that we are going to consider over here is, so suppose there is a dice. I think all of you know about dice. I think all of us has played Ludo in our childhood, right? So suppose I have a dice. So I have a die basically, and then like I'm trying to roll this die three times. So three times I'm trying to roll this particular dice. Now, so someone has told me that, okay, so what is a probability of? What is a probability of? So someone has told me that what is a probability that there won't be any five you will be able to get. So what is a probability that you will not be able to get any five? Because whenever we have a die, so we are going to roll these dice. So for sure we can get any number in between 1 to 6. So 1, 2, 3, 4, 5, 6. But someone has asked me that, okay, so there is a dice, I'm going to roll this dice thrice, let's suppose. So three times. So total number of the experiments which I am going to perform is equal to 3. Let's suppose. Okay. So total number of experiments is equal to 3. Total number of the times for which I am going to roll this dice is equal to 3. Now, what is a probability that I will be able to get? What is the probability that I will be able to, I won't be able to get single 5? So suppose first time I have rolled a dice, I got one. Probability, hypothetically, I'm talking about that. Second time I have rolled a die, so I got maybe like a 6. Then third time I have rolled the dice, I got 3. But I'm not able to get 5 in this particular 3 times trial which I have performed. So someone is asking me that, okay, fine. So what is the probability that if I'm going to roll a die, so there won't be any 5 I will be able to get? That's a question number 1 that we are supposed to solve. The question number 2 is, so what is a probability that there will be only one, there will be only one 5 you will be able to get? I'm not writing all those things in a literature, so it's completely fine. I'm just trying to give you a symbolic representation. So what is a probability that you will be able to get one 5? Or third question I can ask you that, what is a probability that you will be able to get three, all the three times you will be able to get just 5? Means you have rolled a dice, got 5, again rolled a dice, got 5, again rolled a dice, got 5. So you have to find out basically a probability of all of these three things. Now, so I'm supposed to think that, okay, how I'm going to solve this problem. As of now, I think all of you will be able to think about it, because we just talked about one single probability density function, which is nothing but it's a binomial distribution function. So probably you can think that, okay, fine, so somehow I can, or somehow I will try to fit all of my experiments on a binomial distribution function. Based on that, I can try to give you a result. But still, let's try to understand. Let's try to understand that if I'm going to roll my die three times, and then out of three trials, so how many times I will be able to get maybe no 5, or maybe just 1 times 5, or maybe just 3 times 5? Now you can even ask me a question that, okay, why you're talking about all those things? What is the significance of doing that? So whenever you are going to appear for a product based company, for a data science position, so in your first round, which is going to be a written round, there is a very high chances that you are going to get a probability related question for sure. So yes, these things are significant. You are supposed to know about all of these things at any point of a time, and at the same time, these things are not tough. I think we are just supposed to practice with some like a couple of problems, and these things will be done. So you're not supposed to get mastery into these things. It's very easy. I think we all have done that. We are not able to recall it just because it's been a very long time. So if you are able to revise it, I think it's more than enough. You're not supposed to like think that okay fine, these things are too tough, or you will not be able to do it. Okay, so one by one I will start solving a problem. So I'll try to solve a first problem where I'm not going to get any number of the 5 in my 3 trials. Secondly, I will try to solve my problem where I will be able to get just one time 5s. And then third, I will try to solve that okay fine, so what is the probability that I will be able to get 3 5 basically. So means first time 5, second time also 5, third time also 5, I will be able to get. Okay, so let's try to perform one by one. So here the basic idea is either you will be able to get 5 or you will not be able to get 5. Simple. So either you will be able to get 5 or you will be able to get all others, I would say. Now, if I'll talk about a total number of the trial, a total number of the experiment, so that is nothing but basically 3. So I can clearly say that n is equal to 3. Now, so number of success. So if I'll talk about a small n, so in a first case, I would say, so we are expecting number of success is equal to 0. So number of success is equal to 0 means, so the total number of the times where I'm expecting 5 is equal to 0. I have to find out a probability that there won't be any 5. So I can try to say that okay fine, so number of success for the 5 is equal to 0. This is what I'm expecting out of 3 experiments which I'm going to perform. Okay, not an issue. So here I can clearly say that okay fine, n is equal to 0 and capital N is equal to 3, means total number of the trial is equal to 3 and total number of the success which I'm expecting out of this trial is equal to 0. And what is a probability of getting 5? It's nothing but 1 by 6. Now, what is a probability of not getting 5? So it's nothing but, I would say, so 1 minus 1 by 6 is nothing but 5 by 6. Okay, it's fine, not an issue. So here, if I have to find out that what is a probability that there won't be any 5, there won't be means number of 5 is equal to 0, number of success is equal to 0 for 5. If I have to find out, then I can try to represent in this way. So like NC small n, probability of, I would say, so probability of a total number of the so probability of a total number of the success, so which is nothing but a small n into a total number of, I can say, or probability of a failure. This is the formula, this is the binomial distribution formula that we are going to get. So not an issue, it's completely fine. So if I have to find out, so 3C0 into 1 by 6. What is a small n? So small n is nothing but total number of the success. So total number of success is equal to 0. This is what I'm looking for. Total number of the 5 which I can get. So I'm trying to find out that what is the probability that there won't be any 5. That's completely fine. It's equal to 0. Now, so 5 by 6 I can say. So here in this particular place I can try to write like okay 5 by 6, and then to the power capital N minus n, means like a number of a trial minus a number of the success. So number of trial is equal to 3 minus number of success is equal to 0. Finally it will be equal to 3. Okay, so if you are going to solve these things, you will be able to get 0.57. What it says, it says that okay, so there are a 57% chance, or there is a 0.57 probability that you will not be able to get, you will not be able to get what, you will not be able to get 5 in all of these 3 trial or 3 experiments that you are going to perform. So yes, we are able to find out a probability of a non-occurrence of a 5 in 3 trial. So if we are going to experiment something 3 times, so yes, we are able to find out these things in this particular place. Okay, okay, so someone is saying that probability P should be 5 by 6 since we are trying to find out the probability of not occurrence of the 5. So I would like to tell you one thing over here, that I'm trying to consider P as a success. right? So p as a like a p as a success or p as a failure depends, I would say. So depends how you're going to consider your p value. So it could be I can say 5 by 6 if I'm going to reverse this particular case. But in this particular case, what I'm trying to say that, okay, fine. So what is so based on the success, actually I'm trying to find out this probability of occurrences. So here I can say that, okay, fine. So in a successful trial or in a successful event, so the total number of the total number of, or the probability which I will be able to get for occurring 5 in a single trial is equal to 1 by 6, and I'm going to consider that one with that. Okay, suppose we are going to solve a second question. So again, the second question is very easy. So if I'll talk about, like, okay, so what is a probability that I will be able to get 1 5? Last time I have considered a success of 0. That's the reason I have taken p is equal to 1 by 6. If I would have considered the failure of 0, so in that case 5 by 6, this is what I should be able to consider. But here, so I'm trying to talk about a success of 0. Now if I'll try to find out a probability when success is equal to 1, means, so what is a probability that you will be able to get 1 5? Means out of three experiments, what is the probability that at least you will be able to get 5 one time, right? Okay, so I think we'll know all of those things, right? The only thing which is going to change is equal to a number of the 5, or number of the things that, or number of the total experiments out of which you are expecting a success. Okay, so let's talk about it. So I can clearly say that, okay, it will be nothing but 3c1. So 3 factorial divided by 1 of factorial into 3 minus 1 factorial. This is how you can write 3c1. So selection of like a one element out of three element. This is how we try to define a combination. Okay, so here you will be able to find out that it's a 3c1. It's nothing but like a binomial coefficient. Binomial coefficient is equal to 3c1 in this particular case. And if I'll talk about a probability of a success for 5, so it's a 1 by 6. Probability for occurring 5 in a single experiment is equal to 1 by 5 in this particular case, on to the power total number of the success that we are expecting. So total number of success that we are expecting is equal to 1 for sure, into 5 by 6, means into 1 minus p. So total number of what is the probability that we are not going to get 5, which is nothing but 5 by 6, to the power 3 minus 1, which is nothing but is equal to 2. So 3c1 1 by 6 into 5 by 6 square. If you are going to solve it, you will be able to get 0.34, basically 0.347 you will be able to get. So this is a probability. There is a 34% chances that you will be able to get 5 out of 3 trials. So at least or there is a 34% chance that you will be able to get 1 times 5 out of 3 experiment. This is what it says. Now, so if I'll try to find out a third one, again it's very easy, right? So the only value which is going to change will be equal to n is equal to 3. So what is the probability that I will be able to get 5 in all the 3 experiments, or all the 3 trials which I'm going to perform? So it's nothing but 3c3 1 by 6 to the power number of the times success I'm going to get, divided, so into 3 minus 3. Now if you will try to calculate this one, you will be able to get 4.62 into 10 to the power minus of 3. So you will be able to get 0.0462. This is something that you will be able to get. Means there are just a 0.4% chance that you will be able to get 5. You will be able to get 5 in all the 3 trials. Now if you will try to go through a probability, or the final data that you are able to get, or the final value after the calculation that you are able to get, so again these values make sense a lot. How? So whenever I was expecting 0.5, because if I'm going to toss for maybe just a 3 times, right? So whenever I was expecting 0.5, right? So at that point of a time, probability is high. When I have expected 1 times 5 out of 3 experiments, out of 3 trials, which I'm going to perform trial 1, trial 2, trial 3. So out of the 3 trial, if I'm expecting only 1 time 5, yes, it was lesser than a 0 time. So 34%. When I was expecting all the 3 times 5, which is almost near to impossible practically, right? Because if I'm going to toss a coin, and again, if I'm going to toss a dice, for sure I won't be having any idea that, okay, fine, so how many times I will be able to get 5. And that is basically a like a 0.4%, or probability is 0.0046. So this is the probability that I'm able to get, which is very less, which is almost close to a 0, right? That you will be able to get 5 all the time. So whenever you are going to do the experiment, so again, yes, these things are relevant, I would say. These things are relevant to each other. And this is how, so whenever we have a binomial event, or whenever we have like a success or failure kind of a event, right? And you have an idea about the probability of a success and probability of a failure. For sure, if you know probability of success, you will be able to find out probability of failure, which is nothing but 1 minus probability of success. You will be able to perform these kind of like a mathematical operation, and based on that, so you will be able to get your final result. Now, so let's try to solve a few more problem over here. So let's try to solve few more problem on this binomial distribution itself, so that your thoughts will be clear. So here, what I'm going to do is, so there is a blindfolded marksman find that on an average, so there is a person, so who is blindfolded, and he has observed, he has found out that, okay, so whenever he's going to shoot, so he's going to hit the target 4 times out of 5. Now again, I'm repeating my question. Let's try to understand these things in this way. So suppose there is a target. Suppose there is a target. You are supposed to hit. Now, so there is a person who is trying to hit the target. So there is a person who is trying to hit the target, I would say. Now this person claims that, okay, so out of 5 times, suppose he is going to perform this experiment 5 times, means he is going to throw arrow or maybe bullet or something like that 5 times. So out of 5 times, 4 times he will be able to hit. 4 times he will be able to hit. So out of 4 trial, 4 times he will be able to hit. This is something that that person has claimed, right? Now, so if that person has fired 4 shots, so if this person is trying to, so this is what a person has claimed, right? Now, if person is trying to perform 4 experiments, 4 trial, right? 4 trial, then what is a probability? So 4 times, if he is going to throw this particular pin, or maybe you can say arrow or bow, if he is going to throw 4 times, right? So what is a probability that there will be more than 2 times, there will be more than 2 times that person is going to hit? Again, I'm going to repeat my question. There's a person, there's a target, okay? So now person claims that, okay, fine, so if you will give me 5 chance, so 4 times I will be able to hit the target, maybe 1 time I'm going to miss. This is what a person has claimed. This is the original things that we have, which is a claim made by a person. Now, so I'm giving him 4 chances. I'm saying that, okay, fine, so fine, take your 4 chance. And then I have to find out that, okay, so what is a probability that he will be able to hit more than, or he will be able to hit a target more than 2 times, right? So he will be able to, out of 4 times, out of the 4 opportunity, if I'm going to give him, so what is the probability that he will be able to hit a target more than 2? Now if I'm saying that equal to 2, that will be a different case. If I'm saying more than 2 or less than 2, that's a different scenario, that's a different case actually you are supposed to consider. So whenever I'm talking about more than 2, so the total probability, if I'm talking about a probability, so total probability is nothing but a probability of a 3 plus probability of a 4, I would say. Why 3, why 4? I have asked you that what is the probability that the person will be able to hit a target more than 2, and more than 2 means it could possible that the person will be able to hit a target 3 times. It could possible that person will be able to hit a target 4 times. So I'm supposed to consider all of those scenarios. Unless and until I'm not going to consider these scenarios, I will not be able to find out my result or probability for more than 2. So keeping these things in a mind, so we are supposed to calculate that what is a probability that person will be able to hit a target 3 times, what is a probability that person will be able to hit a target 4 times, and then based on that I will be able to find out a final probability. Okay, so if I will try to talk about a binomial distribution or binomial experiment, so yes, this is also a binomial experiment where either person will be able to hit a target or person will not be able to hit a target, as simple as that. So yes, I can say that fine, this is also an event which comes under success and failure kind of a situation. Now, so if you recall, so binomial distribution says that, okay, so NC, sorry, it should be a capital N notation wise. So NCN is nothing but so probability to the power small n, and then Q, which is nothing but a reverse of probability minus n. This is the binomial distribution formula, and this is something that it says. Now, so here I'm supposed to find out that, okay, what is the probability that the person will be able to hit a target 3 times, and what is the probability separately I have to find out, and then if I'm going to combine that probability, then only I will be able to find out that what is the probability that person will be able to hit a target more than 2 times, more than 2. If I said like my last example, so in my last example I was saying that, okay fine, so what is the probability that I will be able to get 5 only one time, or maybe 0 time, or maybe 3 time. But here it's a more than 2, so more than 2 could be 3 or it could be 4 as well, out of 4 trial. So fine, if I'll talk about that, what is a success rate of the person? So success rate of the person you will be able to define from here itself. So success rate of this person, so probability of success of that person is nothing but 4 by 5. So out of a 5 trial, a person is able to hit a target 4 times. So 4 by 5 is nothing but 0.8. What is our probability of failure? So it's nothing but 0.2. 1 minus 0.8 is equal to 0.2. So fine, probability of success we know, probability of failure we know, a number of the times or opportunity you are going to give it to him we know, and we know that what we have to find out. So it's completely fine if I'll try to fit in all those things in this experiment. So I can say that, okay fine, so for 3, so what is a probability that I will be able to, that person will be able to hit a target 3 times? So it's nothing, out of 4 experiments, out of 4 opportunity, so 4C3 into success to the power a number of time we are looking for the success. Okay, so 3 times into a failure and a success, total number of the trial minus, I would say, so success. So 4 minus 3 is equal to 1, plus what is a probability that you will be able to, that person will be able to hit a target 4 times out of 4 times. So it's completely fine, this is what I'm supposed to find out. So 4C4, 0.8 to the power 4, 0.2 to the power 4 minus 4. Now, so if you will try to solve this one, you will be able to get 0.8192. Simple. It's a very simple calculation. I think every one of you will be able to do it. So I can say that, okay, fine. So there is a 81% chance that that particular person, 81.9% chance precisely. So there is a 81.9% of the chance that person will be able to hit a target more than twice. So this is what you will be able to get in this particular place. Now, so again, the another question that we have is, this is the question number one that we had. Now the question number two that we have over here is, so what is a probability that that person is going to miss at least three times? Means out of four times, if I'm giving him an opportunity, what is a probability that that person will be able to miss at least three times? A person is going to fail, a person is not going to hit the target. So let's talk about that. So I can talk about this one in this way as well. So I can say that, okay, fine, so what is a probability that there will be only one hit? There will be only one hit out of the four experiments. Or let's try to understand in this way. So if I'm saying that, okay, so what is a probability that that person is going to miss a target at least three times? Now, so a simple meaning is, so three misses, so three times he is going to miss the target. So it simply means that, so he is going to miss three times and one hit I'm expecting, or four miss or zero hit I'm expecting. Because here my question was, so what is a probability that that person is going to miss at least three times, or person will not be able to hit a target at least three times? Just try to focus on my word. So when I say that, okay, at least three times this person will not be able to hit a target, it simply means that okay, so even if person is going to miss all the four times, it will be able to fulfill a same condition, that at least, I'm saying that at least three times. Here, I have very clearly written that at least three times this person is going to fail. So, whenever I say at least, so you are supposed to focus in this particular words, and at least means I can fail three times. That's also comes under at least three, and I can also fail four times. That is also coming under at least, I would say. So, I'm supposed to find out this failure cases for three, as well as I'm supposed to find out this failure cases for 4. So suppose if I'm trying to consider this particular failure cases, so if I'm going to miss three times, then what is the number of the times I will be able to hit the target? One time. If I'm going to miss four times, what is the number of the time I'm going to hit the target? Zero times I'm going to hit the target. So this is success. This is also success. So in both of the cases, so if somehow I'm able to find out a success of 1 and 0, success and summation of 1 and 0, yes, I will be able to tell that, okay, fine, so like at least this is the like this is the percentage, or this is basically like a number of the time that particular person is going to miss a target at least three times. So fine, not an issue, I can try to solve it. So again, it's a binomial problem itself. So I can try to write my line in this way. If I'll talk about maybe first cases where there will be only one success, person is going to miss at least three, means there will be one hit that person is going to give it to me. So now I can write like in this way, 4c1 and 0.8 to the power of success, 0.2 to the power of total number of experiment is equal to 4 minus success is equal to 1, plus I can write in this way. So 4 failure means 0 success. So 4c 0, 0.8 to the power number of times success, 0.2 to the power 4, in this particular way. This is one of the equation. The other kind of equation which I can write in this particular place is, so based on 3 and 4. So 4c3 3 is what? 3 is a total number of the failure. So total number of the failure. So how, what is the probability that I will be able to fail for 3 times? So that is nothing but 0.2 to the power 3, 0.8 to the power 4 minus 3 plus what is the probability that I will be able to fail all the 4 times? So 4C4 and 0.2 to the power 4, 0.8 to the power 4 minus 4. Both of these things are same. You can write in this way or you can write in this way. The only thing which you are supposed to consider is so total number of a success or failure that you are going to consider. You're just supposed to change this particular part and then it's completely fine. So both experiments are going to give you the similar kind of a things. So it's completely fine, guys, I would say. So in both the cases now, so if you will try to find out the final result, you will be able to get this final result is equal to 0.02, means there are a 0.02 probability, or there is a 2% of the chances that person is going to miss at least 3 times. There are only 0.02% of the chances that person is going to miss at least 3 times. A simple one, a very simple one that we are going to consider. So it's completely fine. So this is something that you will be able to solve based on the binomial distribution. There are many more problems that you can solve based on the binomial distribution. So I'm going to give you all of those problem statement in your basically slides as a question. So just try to solve it, just try to solve it by yourself, and I think you all will be able to understand it, you all will be able to get these particular things. Now the another one, so I think this is all about a binomial distribution, or like a binomial probability density function. So where we were trying to consider a binomial event, means a event which can give you a success or which can give you a failure. And for that, so we were trying to find out a probability factors of a different kind of events that we can have. Now the second one, second distribution function which I would like to talk about is a Poisson's distribution. So first of all, like I told you, we'll try to finish the simplest one, so binomial, and then let's talk about Poisson's. We'll be talking about all kind of a distribution, because normal distribution, uniform distribution, student t distribution, so these are a very much important distribution. Again, formula wise there is nothing, but still these things are very much important and we will try to talk about it. Now let's try to consider what is a meaning of a Poisson's distribution. In what cases you are supposed to use binomial, and in what cases you are supposed to use a Poisson's distribution. It's not like every time, so you can use just a Poisson distribution and then based on that you will be able to find out the result, or every time you are just going to use a binomial distribution and then you are going to find out the result. Because probability is one of the very important thing that we use to find out, or our algorithm try to find out all the time by itself, every time. So whenever we talk about a probability, so most of the time you're not supposed to take a pain whenever you're going to do some kind of an implementation in a machine learning or deep learning. So system try to do all of those things by itself. But yes, what I feel is like, okay, you should know about that and you should able to correlate. So if you know all the different kind of a distribution, for sure you will be able to correlate. So fine, guys, let's try to understand and let's try to find out that what is a meaning of a Poisson's distribution and what exactly it does. So here I'm going to talk about Poisson's distribution. So it's different. I would say it's different from the binomial distribution that we have discussed. In binomial distribution, we have discussed that if my events are by, means if my events is going to give me a success and failure kind of a result, and if success and failure both are independent of each other, so in that case I can try to use a binomial distribution. Now if I'll talk about a Poisson distribution, so Poisson distribution you can use to find out a probability in between some time period or event of occurrences of, or maybe a probability of occurrences of some kind of a event in a certain time period if you are supposed to find out. I was giving you an example. So there is a road accident in every 1 hour. Let's suppose there is a five accident which happens. Now, what is the probability that in next 1 hour I can expect 10 accident? This is also comes under interval. So in 1 hour, in general, there are like a five accident which happens. What is the probability that in next 1 hour or maybe in next one day I can expect 10 accident? That is also, that is like a probability. Suppose suppose so, like in a car wash or in a garage, so there are maybe a 10 car per hour. I'm expecting 10 car per hour I used to get in a single hour. What is the probability that I will be able to get maybe 100 car in a entire day? So again, this falls under a probability and this falls under a interval. So we are trying to consider a interval over here, a time interval or maybe some spatial interval that we are going to consider. And based on that, so we are trying to find out the probability. So if you have some kind of experiments, if you have done some kind of experiments where events are dependent on a interval, where independence or like events are dependent on the interval, and all the events is going to happen going to happen in an independent way. So feel free to use a Poisson's distribution. Poisson's distribution has been used all the time to find out, I would say, to find out a probability of occurrence of some event in between a interval. So whenever interval comes into a picture, you should not talk about a binomial distribution. Simply you can try to use a Poisson's distribution, and this is going to simplify your life at any point of a time. So fine guys, let's try to understand it, right? So let's try to understand that what kind of a problem that we will be able to solve based on the Poisson's distribution. So formula wise, if I'll talk about a Poisson distribution, so probability is nothing but, or probability for the Poisson distribution is nothing but e to the power mu into mu to the power x divided by x factorial. So this is what you will be able to get as a Poisson's distribution. So e to the power minus of mu into mu to the power x divided by x factorial. So I think we all know that what I'm trying to refer through mu, and we will try to find out that what we are trying to refer through x. If I'm able to find out a mu, if I'm able to find out a x, my life will be easy and I will be able to find out maybe a probability. So probability, what kind of probability? Let's try to figure it out and let's try to check that. Okay, so what kind of problem that I will be able to solve? So problem statement wise, let's suppose there is a salesman. There is a salesman so who used to sell a insurance, right? So there is a salesman so who used to sell a insurance, I would say. So there, so my question over here is, there is a salesman who used to sell three insurance per week. Okay, so there is a salesman who used to sell three insurance per week. That is completely fine. On an average, I would say, on an average, like that person used to sell three insurance per week. Now, so what is a probability that in a current week, what is a probability like that he will be able to sell maybe a two or more than two policies? So what is the probability that that person will be, so on an average, so that person sells basically like three insurance per week. Now I can try to find out that, okay fine, so in the current week So what is the probability that he will be able to sell maybe like a 3, or maybe like a 10, or maybe lesser than 10, or maybe lesser than 3, greater than 3 sales, that particular person will be able to do it. Now here just try to observe one thing, just try to observe one thing in this particular place, that I'm talking about per week. So I have given you the interval, so I am saying that okay, so on an average, the sales made by the person in a week, means in this interval, I'm talking about interval over here. So in this particular week is equal to 3. So I can clearly say that, okay, mu is equal to, means average sales, because mu is nothing but it's a representation for average or mean for a population, right? So okay, on an average, that particular salesman is trying to sell 3 insurance. So find average is equal to 3 per week. This is the bi-weekly average, I would say. Now, so based on that, so I can try to find out that, okay, fine. So what is the probability that that person will not be able to sell anything this week, or maybe more than 10, lesser than 10, in between 5 to 10, many things we can be able to find out in this particular week. Remember that, right? So fine, guys, let's try to find out, let's try to like solve these things one by one, right? So here, the first question which I'm supposed to solve, the first question which I'm supposed to solve, that so in a given week he will be able to sell how many policies. Suppose if I'm going to ask you a question that, okay, so this is like a data which has been given to you, there is a salesman, 3 insurance per week he used to sell. Now so in a given week he will be able to sell how many policies, if I will ask you that, okay, you have a salesman under you. Now how many policies that particular person or particular sales person will be able to sell in this particular given week. So I can try to solve these particular problem. It's completely fine. I will be like able to find out, or I will be able to solve these particular things. We already know that, okay, fine, so mu is equal to 3, mu is equal to 3 in this particular place. And we can try to say that whenever he will be able to sell a policy, whenever he will be able to sell a policy, that will be equal to 1. Whenever person will not be able to sell a policy, that will be equal to 0. So I can say that, okay, fine, so it could possible that person will be able to sell it, or maybe person will not be able to sell it. So if let's suppose so I'm trying to like just find out, I'm just trying to figure out that what is a probability that that person will be able to sell this week. So if I have to find out that, okay, so person will be able to sell or person will not be able to sell, so in that case I can say that, okay, fine, so even if person will be able to sell only one policy, I can say that, okay, fine, person has sold something, right? This person has sold something. But if I'm trying to ask that, okay, fine, so what is a probability that that person will not be able to sell anything, what is the probability that that person will not be able to sell anything? So in that case sales is equal to 0, I may consider in this particular case. So let's suppose we are trying to find out that what is a probability that that person will not be able to sell anything this week, right? Or at least one thing that person will be able to sell, or maybe at least two things that person will be able to sell. I can try to find out, that is not an issue, it's completely fine. I can try to find out the probability for doing that. So let's suppose if I'm trying to find out that, okay, so whether what is the probability that this person will be able to sell something. Sell something means what? Sell something means, so maybe 1 minus probability of 0 sales. What is a probability of 0 sales? If I'm able to find out, if I'm going to subtract from 1, so I can say that, okay, fine, so this is a probability that that person will be able to sell something, because this is a probability where person will not be able to sell anything. Okay, now let's try to find out based on the Poisson's distribution formula itself. So Poisson's distribution formula says that, so suppose person will not be able to sell anything, it says that e to the power minus of mu x to the so mu to the power x, mu to the power x divided by x factorial. Now, so we have to find out probability of a no sale is equal to, I can say, e to the power, so minus of mu. So on an average, person used to make three sales. It's completely fine. So three sales to the power the total number of the sale that we are expecting. So we are not expecting any sales. So 0 divided by 0 of factorial. 0 factorial is always going to be 1. So in this way, you will be able to find out that this result is going to be 0.04. My bad. Okay. 0.0497 you will be able to get. So there is a 4% chance that that person will not be able to sell anything. Now if I have to find out that what is our chances or what is the probability that person will be able to sell something, so it's nothing but 1 minus this probability of x of 0. This is the probability that person will be able to sell something. So 0 minus 0.0497. So if you will try to do a computation, so 0.95021, this is the probability that person will be able to sell something, at least one thing person will be able to sell, because whenever person will be able to sell something, he can sell maybe 1 2 3 4 5 6 10. So if I have to find out that, okay, so what is the probability that person will be able to sell at least one thing, one item, at least one means it can go till any number. So if I have to find out, then that's completely fine, I don't have any issues. So maybe probability 1, because total probability is going to be 1 anyhow. So 1 minus person will not be able to sell anything is going to give me person will be able to get sell something. So fine. Now the next question or the next experiment that we are going to do over here is, so what is a probability? Suppose this is the same statistic, same data set which is given to us. Now another question that we have over here is, so what is a probability that selling, so what is the probability of selling, I would say, two or more policies? So what is the probability that person will be able to sell more than two but less than five in between? So what is the probability that person will be able to sell, I would say, more than two, but lesser than five policies? So if you have to solve this kind of a problem, so in that case what you can do is, so it's simple claim that what is a probability that, like a probability of selling two or more than two policies but lesser than five. Now just let me write it down in a better way. So if I'm going to write it down, that what is a probability that person is going to sell more than or equal to 2 and lesser than 5, this is what we have to find out. So I can try to say that, okay, fine, so probability of selling 2, probability of selling 3, and probability of selling 4 will come into a picture basically, so to solve this particular problem. So now what is a probability that person will be able to sell more than 2 and lesser than 5 in an entire week? More than or equal to 2 or lesser than 5. Equal to symbol is there, that's the reason, so I'm trying to take 2. There is a no equal to symbol, that's the reason I'm not trying to take the upper bound. As simple as that. If someone is going to give you that what is the probability that a person will be able to sell more than or equal to 2 or less than equal to 5, in that case for sure I would have considered this as well. Okay, so here what you will be able to find out is, okay, so probability of 2, probability of 3, probability of 4, again formula is same, because based on the Poisson distribution we are supposed to find out. So it's nothing but e to the power minus of mu to the power x divided by x factorial. So here I can try to write it down, e to the power minus of 3, and then so average 3 to the power 2 divided by 2 factorial, plus I can try to write e to the power minus of 3, 3 to the power 3 divided by 3 factorial, plus e to the power minus of 3, 3 to the power 4 divided by 4 factorial. So it's completely fine, because it's nothing but success is equal to 2. So x is equal to 2, x is equal to 3, yes, and x is equal to 4. Now if you will try to find out a combined probability, so it's nothing but there is a 61% chance that person will be able to sell more than 2 and less than 5, more than equal to 2 and lesser than 5. So in this way you will be able to find out again a result of this particular example. Likewise, there are many more example which is already mentioned inside your inside your slides, which we are going to publish in your dashboard for sure. So this is I would say this is again one of the example that you will be able to find out in terms of a Poisson's distribution. So again, it's a interesting one, I would say. So it's an interesting things that you will be able to find out. So where we try to do experiments based on the interval. Let's try to solve a couple of more problem in a Poisson distribution so that these things will be very much clear, right? So let's suppose there is a editor, there is a book editor. So there is a guy who is a book editor, okay? So or maybe like a book validator, you can say. So they try to edit a book, they try to validate a book, they try to do a spelling correction, all the mistake correction and everything, okay? There is a book editor who is available, who used to do all of these operations. Now, so on an average, so now on an average, I can say, so out of 100, out of 100 pages, on an average, a person used to get 1.5 in 1.5 word. Person used to get some kind of person used to do some kind of a correction. Means there is a average mistake of 1.5 person used to find out. Average mistake of 1.5 person used to find out of 100. Now, so this is 1.5 is just an average out of 100. So 100, I can say 100 pages is nothing but it's an interval. So if a person is going to validate 100 100 pages of a particular book, he found out that okay fine, so there are like a 1.5 average on an average mistake in a 100, first 100, then second 100, then third 100. Okay. Now, so if there is a editor, same editor is going to pick and choose 100 pages from a new book, right? So 100 pages from the new book. Now, so if person is going to select 100 pages from a new book, I would say, so what is a probability? What is a probability that there won't be? So probability there won't be, I would say, any mistake. So what is the probability that there won't be any mistakes which person will be able to find out if he is going to select 100 pages? Okay. So this is what I'm supposed to find out. So I completely know that, okay, fine. So per 100 pages means per interval, because again, here you will be able to find out a case of an interval. So here you will be able to find out that, okay, fine. So in a particular interval, so I used to get in a particular interval, I used to get on an average 1.5 errors. Now, so what is the probability that, okay, if I'm going to pick like 100 another page from some other books, I will not be able to get any kind of a mistake? That's very simple. It's not a big deal at all. So basically, I'm looking for a zero mistake. What is a what is the probability that I will not be find out any mistakes? Means a zero error, zero mistakes. I'm looking for. Now, so if I'll try to fit in to this formula, so Poisson distribution formula, it says that e to the power minus of mu x, or okay, in this way. So mu to the power x divided by x factorial. Okay. So fine, on an average, I can say that mu is nothing but 1.5. 1.5 on an average mistake that we used to get in an interval means 100 pages. So e to the power minus of 1.5 into 1.5 to the power x. Now, what is x? Means zero. Zero mistakes we are expecting. So in this particular event, divided by 0 factorial, if you will try to do a calculation, you will be able to get 2231. So there are 22% chance that you will not be able to find out any kind of a mistake if you are going to pick 100 pages from a new books. So this is again another thing I would say, which you will be able to find out right now. So again, on top of the same thing, so if I'm going to like tell you that, okay, if I'm going to ask you that in 100 pages you are able to get 1.5 mistake on an average. If I'm asking you a very simple question, maybe a stupid one, that what is a probability, or like not a probability, so what is the average mistake that you will be able to get? Or let's suppose if I'm going to ask you a same question, that if I'm going to consider maybe, okay, so if I'm going to ask you a question, that if I'm going to consider a 400 pages, if I'm going to consider a 400 pages, what is a probability that there won't be any mistake, or there will be a zero mistake if I'm going to select 400 pages, right? So for 100 pages, mistake is equal to 1.5. That is completely fine. For 100 pages, mistake is going to be 1.5. But if a person is going to select 400 pages, what is a probability that there will be a zero mistake person will be able to find out? So again, that is not an issue. I think we all will be able to find out that what is a probability that person will be able to get a zero mistake in 400 pages, because for the interval of 100, for the interval of 100, I know the probability. So for the interval of 400, up like a for the interval of like 100, I know the number of mistakes, and I know the average mistakes. For the interval of 400, I can assume that, okay, so it will be nothing but, so 100 into 4. So if you are going to multiply these things by 4, you will be able to get them 400 as an interval. So if in 100 pages there are 1.5 mistake, then in 400 pages there will be 1.5 into 4, which is equal to 6. So in this interval there is actually, so in a 400 pages interval, actually there are 6 average mistakes that you will be able to get. Now if I'm asking you a question that what is the probability that there will be a zero mistake, there will be a zero mistake, it's not an issue. You will be able to find out for the 400 pages, because we know the average mistakes that we are going to make in this particular place. As simple as that. So just try to change the value of average over here, right? X value will be same, and then you will be able to get a same probability for some other interval. So likewise, there are many more situations, there are many more possibilities are there, which you can try to determine based on the intervals. And again, there are many more formulas, like there are many more cases where you can try to apply a similar kind of things in this particular place. So I would say that this is all about Poisson's distribution. Now if I'll try to conclude, so binomial distribution always try to talk about a event which is going to give you a success or a failure, right? Success or a failure. And if you have to find out a probability of a success of out of n number of a experiment, so probability of number of the success out of n number of experiments, yes, you can go ahead with the binomial distribution. But again, it always consider success and failure, means it always consider two class, I would say, either zero class or one class, or success or failure class, yes or no class, I would say. Now, so if I'm trying to talk about some interval, a probability in between some interval, so in that case, I can happily go ahead with a Poisson's distribution, because Poisson's distribution always talks about a interval. So whether it's a time interval or interval of the book pages that we have taken, I would say, or any kind of interval. When I say interval doesn't mean that I'm just talking about a time. I'm just talking, so interval simply means that I'm talking about experiments maybe in between certain range, or like a certain subset of the or the elements, I can say. So that's completely fine. So I think we have covered this two things, like a binomial, and we talked about, I would say, like a Poisson distribution. So these two things is done. These two things is done. Now in tomorrow's class, I will be talking about most important concept called as normal distribution, because this is something we always try to apply all the time, not just by writing a code by ourselves. There is a library which is available, but yes, this is having a huge impact on any kind of like any kind of a model that you are going to build. And again, I will be talking about a student t distribution, I will be talking about a uniform distribution, I will be talking about a z statistics. Plus we will see that how we can try to check a value into a z table. So like in a childhood, so we used to look into a log table, right? And as of now, no one does that because we have a calculator. But when we were child, so yes, we used to do that. We used to look into a log table, right? Because calculator was not allowed at that point of a time in our childhood. So yes, so basically we'll be talking about like a jet statistics, we'll be talking about like a t statistics in between. So yes, just try to revise these things are not very tough, I would say. It's very easy. And yes, people are going to ask you a direct question, people are going to ask you a direct question in your like a product interview whenever you will go for some kind of a product company as a data scientist. So yes, they always try to give you a 3 4 questions out of maybe like a 20 30 questions. At least 3 4 question you can expect in this particular area in your written round, which will be a first round or which will be a qualifying round for you for sure. So just prepare accordingly, guys. And I think I can take some questions from your end. Okay, so basically I'm going to upload some of the questions in your dashboard, guys. And what you can do is, so just try to go through all the questions which I'm going to upload. I will try to upload maybe a solution as well. Okay, I think I'm visible to every one of you. So I will try to upload questions. I will try to upload solutions as well along with the questions. Just try to do this experiments by yourself. I think that will be better, right? That will be a better for practice. And it's nothing, it's just like you're supposed to understand that, okay fine, so in which case which one I should use, right? And name itself talks about like many things. So just try to go through it and let me know if you are facing any kind of a issue, right? So maybe I'll try to consider it. Tomorrow I'm going to talk about a very important concept, gender statistics, a normal distribution. It's very much important. And again, there are many things you will be able to get, you will be able to understand in terms of a data. So how, when we say we are going to standardize a data, we are going to normalize a data, what is the actual meaning? Because many of you must be confused about a data normalization or maybe data standardization. So in tomorrow's class, I will be talking about those things: data statistics, t statistics, data normalization, data standardization. If I have a normalized data, how we can convert those normalized data mathematically from to the to the standard like a standard normal distribution, and many more things comes into a picture. So make sure that you attend tomorrow's class to understand all of those concepts. And in between, just try to practice. I'll try to upload these things maybe by evening, this same exercise and assignments. People who are existing student, so you can just check your dashboard in your stats part. It's already available in your stats section. So you will be able to find out a statistics underscore one. So just try to download that one. Questions are available in that one. So for the practice. And again, so there is assignments that we have given to you. So assignments are already available in your section. People who have joined through a community event, so in your dashboard this things is not available. We'll make sure that by evening this things is available for sure. With that, guys, thank you so much. And I think I can take a couple of questions at least from some of you. So go ahead and you can ask question. Yeah.
Yeah, these are methods which can be applied for classification models.
Yes,
Like,
yeah. So
what about
basically,
regression models?
classification is nothing but, so somehow we try to find out the probability starting from a very simple equation, which is a logistic SVM or maybe I can talk about decision tree as well, because decision tree internally uses entropy. Entropy is nothing but log of p minus of p log of p, or information gain, or maybe a gain indexing ID3, or if I'll talk about maybe like XGBoost. So everywhere probability functions that we use. In case of a regression, as you have asked, so generally we try to use a linear regression, or maybe a polynomial regression, a multinomial regressions. We are going to use it. So again, those things also we are going to discuss, right? But in your machine learning class. Okay.
Okay.
Yeah.
Yeah. Hi, Sudhanshu. Rohit here.
Go ahead.
Yeah, actually, I have a doubt. Like in the Poisson distribution, you told about the intervals we are going to work on.
Yes. Yeah.
So, like, my question is like in the last example you give for the 400 pages, how many mistake will be there? Like for
Yes.
the 100 pages, we have calculated 1.5. So, is it like
Yes.
uniformity will be there? Like for 100 pages, then 1.5 in 200 pages.
Hypothesis we can build actually. So basically what happens is, suppose if a fact is not given, right? If facts is not given, in that case, what we used to do is, so I'll talk about a hypothesis theorem as well. And we have to do a lot, because hypothesis is like a very powerful theorem when we talk about a statistics. So hypothesis we used to build that, okay, fine. So if this has happened, so this is my assumption, right? If nothing
Right.
is given, in that case I used to assume, basically, right? Whether it's a true or whether it's a false, we'll evaluate in a later stage, but we try to make assumptions, and that falls under hypothesis. So yes, we can, I can assume that whatever you are thinking is correct from your perspective. I'm not saying that it's incorrect, but yeah, so there is something called as a hypothesis, there is something called as assumptions that we used to build, and based on that assumptions, I'm saying that, okay, fine. So if something has happened, means if there is a 1.5 mistake which I have made in my 100 pages, right? And now if I'm trying to talk about a 400 pages, so it will be almost a fourfold of the 100 pages, right? It could be
Right.
incorrect. I completely agree with that, but as of now I don't have a facts, right? So I'll build
Right.
my hypothesis. Making sense?
Yeah. Yeah. Sure. Sure. And one more question I have.
Yeah.
In the binomial distribution, like you have taken n as a 4. So
Hmm.
it should be 5 or 4 because the total cases are 5 hits, right? Out of
Which
which
one?
4
Which
are
one? No,
success
no, no,
and
no. Just tell me which one. I'll give you the clarification.
yeah, binomial distribution. But that you have taken the example of 4 hits are success and one hit is failure out of 5.
Which one?
About that hit one you are telling about, how many hits is going to consider like for at greater than 3, at least 3. You have taken the and
Okay. Okay, at least three times, right? Yeah.
yeah, yeah, yeah.
Okay.
Basically, my question is like in the binomial distribution, like in the formula NCR, number of selection that we are going to do after out of n. So
Okay.
n should be 5 or 4. Basic doubt is like this.
So see what happens over here is, so when we are talking about a capital N, just try to understand this particular one, okay?
Okay,
So when I'm going to talk about a capital N, or I think I should have used a different notation. I completely agree with you. So NCR, or let's suppose this is what I'm talking about, right?
right,
So is what? So this N is nothing but a total number of the trial that you are going to perform, right? And
right.
R is nothing but out of this trial, how many times you are going to calculate a success or a failure. Is it making sense?
Yeah, yeah,
Yeah. So when I say that, okay, at least three, right? When I say at least three, this is what I have written, right?
right.
So at least three, or like at least three means what? So at least three means
3, 4, 5,
three, it could be
4.
4. This is also like, so total number of, so I said that, okay, fine, so total number of experiment which I am going to perform is equal to 4, right? That is the
Right,
total number of experiment. In total, I'm going to give you how many chances I'm going to give you. I will give you 4 chances. Fine. Now out of 4 chances I have given you, and now I'm asking you to solve a particular problem, right? Or maybe I'm asking you to hit the target, right?
right,
So I
right,
have given you 4 attempts to do that, right? Now I'm asking you a question, that what is a probability that out of this 4 attempt which I have given you, at least 3 times you will be able to perform this thing successfully, right? So can
right,
I say that at least 3 means 3 plus 4?
right.
Agree on this label? So out of 4, can I write that I should find out 4C3 and 4C4,
Right. But
right?
total observations are 5 na? Or it is
No,
4?
no. This is what I have given you as a data that, okay, so on an average, what happens is out of 5 hit, so basically you need a value of P. I know where you are making a mistake. So can I say that? So when I say that out of 4 times, so when I say that, okay, fine. So what is a probability that out of 4 times, now 4 times, if I have given you a chance, so you will be able to hit it at least 3 times or just 3 times, right? So can I
Right.
say that you need a probability as well, that, okay, so if you are going to hit some target, right, so what is the probability that you will be able to hit, or what is the probability that you will fail?
Right, right.
You need a p value as well. Can I say that you need a p value,
Right.
right?
One P and
And
one Q, success and
yeah, so
failure.
to give you a p value, so in a very beginning I said that your performance sheet says that out of 4 in general you hit 4 target. I
Right.
think there is a confusion between numbers, so let's calculate in this way. So suppose out of, on an average, so you try to hit the target out of 10, like a trial, so you try to hit on an average 8 target. Means what is a probability of success for you? Probability of success for you is 0.8. Can I say that?
Right. Yeah.
So basically this is, so don't try to mix up these things and this one. So this is the question which I've asked you, that, okay, fine, so this is your performance, this is a performance which it says that, okay, fine, so your probability is 80%, right? Your performance is 80%. So out of like a 5, if I'll give you 5 chance, then you will be able to at least hit four times, right? This is what it says from your track record, from
Right.
your
I
historical
got it.
data, right?
Okay.
But this
Right.
time I'm not giving you 5 chances, I'm just giving you 4 chances. So maybe I'll just give you 3 chances. Now I'm asking you that, okay, fine, so out of 3 chances, how many times you will be able to hit, or what is the probability that you will be able to hit 3 times? Is it making sense?
Yeah. Yeah. Now it is clear.
Clear, right? Okay, that's great. So
Okay.
this is what
Thank
I
you.
was trying to say. So don't try to mix both things, and whatever calculation I have done, so it's exactly correct,
Yeah.
and I have not made any kind of a mistake in my
No, no,
calculation.
no, not from your end. Just I have a doubt, so
No, no,
just
I know that where you got this doubt. So I think now it's clarified, right?
yeah, yeah, yeah. You are talking about in the terms of number of hits that is going to be done, and out of that you are taking
There
the
will be a
distribution.
facts, right? There will be a facts. There will be a
Right.
fact saying that okay, fine. So this is your performance. So if this is your performance, then what will be a probability that you will be able to perform now in this way? Yeah.
Yeah, yeah.
Okay,
Thank you.
so
Thank you.
yeah, so I think fine, guys. I would like to like take a leave now. Yeah, and I'll make sure that in your community dashboard, so these things are available. Like a couple of questions will be available, so that you can try to go through that. And again, solutions will also be available. Plus assignments. So yes, at the end of the session, maybe by tomorrow end. So I will upload some of the assignments as well, just for your practice. Those assignments are not that easy. Try to solve it and try to like spend some time with that, and try to solve those assignments. It will be really a helpful one. It will help you out to revise the concept that we forgot, because what I'm assuming is like everyone knows about probability, everyone has studied probability at some point of a time, but we are not able to recall it, right? These concepts are important. It make your life easier to understand algorithm, I would say. And implementation wise, neither an algorithm nor a probability things is tough. If I'll talk about a Python or maybe any other languages, it's just so we have written this entire page of mathematics just to solve one single problem. But if I'll talk about implementation, it will be a simple small functions by which you can implement it. So implementation wise, don't worry about that. It's very easy. Maybe at the end of this entire community event, I'll show you a mathematical function as well. I have all those things written. I'll just pass my data, and then I'll be able to get this kind of a rate, like a calculation easily, just in a fraction of a second in a single line. So with that, guys, thank you so much. See you again in tomorrow's class, same time. With that, thank you so much. Have a great day ahead.